Question 72. Which one of the following presents a pair of resonance structures? So we've got to use those three rules that they've given us in the STEM in order to answer the question. Rule 1 is particularly important, so only electrons may be shifted to adjacent atoms or bond positions. So this means that atoms aren't being shifted, only electrons. So what we'd expect to see in our resonance structures is that they do not differ in the position of the atoms within each of these structures. Only the position of the electrons changes. So let's try and answer question 72, starting with A. So CH3, C, CH2, OH, we've got that in our two structures, except the most important thing to note is that the position of our atoms are different between these two structures. So as according to rule 1, these two structures cannot be resonance structures because they're not differing only in their electron positions, but also in their atom positions. Answer B has similar problems in that they differ in their atom positions between the two structures. So as you can see, we have a CH3 here, but over here on the second structure, it's only a CH2. So this hydrogen has moved over down towards the oxygen. So these two structures therefore cannot be resonance structures. So let's just skip C for a quick moment and move on to D. D is incorrect, but for a slightly different reason to A and B. So in rule 1, it states that only electrons may be shifted to adjacent atoms or bond positions. In D, what we've got is electrons moving, which is good, but the electrons aren't moving to adjacent atoms. They're moving to an atom just one over from its adjacent atom. And you can see this here. This right-sided electron is going to be moving over to the left, but it's going to skip this middle carbon. So we don't have adjacent electron movement in D, so making D incorrect. And C is obviously the only answer remaining and the correct one. And it's also correct because only electrons are moving, not the positions of the atoms, and electrons are only moving to adjacent atoms. Question 73, consider the resonance structures 1, 2, and 3 shown below. Which one is the major contributor to the real structure? So again, 73 is like 72 in that a little bit of reading comprehension will go a long way. And if we refer to rule 3, the more important resonance structures show each atom with a complete octet and with as little charge separation as possible. Well, in this case, in 73, structure 2 has the least charge separation as possible. So therefore, it is the correct answer, and therefore B is the correct answer for question 73. Question 74, consider the two reactions. Which one of the following best explains why phenol is a much stronger acid than cyclohexanol? So if we want something to be a stronger acid, what we essentially want is we want the deprotonated form of the acid to be much more stable. And the reason for that is because if it's much more stable, then it's going to be much more likely to donate those hydrogen atoms. As such, coincidentally, a benzene ring is a much more stable structure. And the reason for that is the negative charge on the benzene ring is delocalized over the entire benzene ring, making it a much more stable structure. So therefore, what we'd expect to see is that the benzene ring molecule will be a much stronger acid than the non-aromatic molecule. So therefore, phenoxide as a aromatic molecule will be a much stronger acid than cyclohexide. So therefore, C is the correct answer.